Hey there, homeowners and builders. Let's talk concrete. It's everywhere. Our homes, bridges, roads. It's tough stuff, right? Well, even concrete can have problems. We call these problems concrete distress. Distress is a fancy word for damage. Cracks, crumbling, rusty rebar. These are all signs of distress. It's like your concrete is trying to tell you something's wrong. Ignoring these signs is a recipe for disaster. Now, you might be thinking, my concrete looks fine, but remember, problems often start small. A tiny crack today could become a major headache tomorrow. That's why it's so important to understand concrete distress and what to do about it. We need to catch these issues early. Early detection means easier, cheaper repairs. Plus, it keeps your structure safe and sound. So let's dive in and learn how to keep your concrete healthy and strong. Concrete distress is more than just a cosmetic issue. When you see cracks in concrete, it's easy to dismiss them as minor imperfections. However, these cracks can be indicative of much deeper problems that, if left unaddressed, can lead to significant structural failures. It's a sign of underlying problems that can compromise the strength and durability of your structure. The integrity of a building relies heavily on the condition of its concrete, and any signs of distress should be taken seriously. Cracks are one of the most common signs of distress. They can appear in various forms, such as horizontal, vertical, or diagonal, each type potentially pointing to different issues. They can be caused by a variety of factors like shrinkage, settlement, or overloading. Shrinkage cracks often occur as the concrete dries and loses moisture, while settlement cracks can develop if the ground beneath the concrete shifts. Overloading, on the other hand, happens when the weight on the concrete exceeds its capacity. But don't panic at the first sign of a crack. It's important to assess the severity and cause of the crack before jumping to conclusions. Small, hairline cracks might not pose a significant threat, but larger, more pronounced cracks could be a cause for concern. Not all cracks are created equal. Some are merely surface level and don't affect the structural integrity, while others can penetrate deeper and compromise the stability of the structure. Some are harmless, while others can indicate serious structural issues. It's crucial to have a professional evaluate the cracks to determine their cause and the best course of action. Another common problem is corrosion. This often goes unnoticed until significant damage has occurred. This happens when the steel reinforcement bars, rebar inside the concrete, start to rust. The rusting process can expand the rebar, causing the surrounding concrete to crack and weaken. Corrosion weakens the rebar and can eventually lead to concrete spalling, where chunks of concrete break off. This not only affects the appearance but also the structural integrity of the concrete. Other signs of distress include discoloration, scaling, which is the flaking or peeling of the concrete surface, and efflorescence, a white powdery substance on the surface. Efflorescence occurs when water moves through the concrete, bringing salts to the surface and leaving a white residue. Each of these symptoms points to a different underlying cause, and understanding these causes is key to finding the right solution. By identifying the root of the problem, you can take the necessary steps to repair and prevent further damage, ensuring the longevity and safety of your structure. Concrete is designed to carry weight. That's its job. It's a material known for its strength and durability, used in everything from sidewalks to skyscrapers. But its ability to bear weight is not infinite. But too much weight, or weight it wasn't designed for, can cause serious problems. When concrete is overloaded, it can crack, buckle, or even fail catastrophically. This is why understanding the limits of concrete is so important. We call these structural loads. Structural loads are the forces, deformations, or accelerations applied to a structure or its components. These loads can come from various sources, including the weight of the structure itself, the weight of the occupants, and environmental factors like wind and earthquakes. Think about a bridge. It's built to handle the weight of cars and trucks. Engineers carefully calculate the maximum load a bridge can support to ensure safety and stability. But what if a huge overloaded truck tries to cross? This scenario can push the bridge beyond its designed capacity. That extra weight can cause stress, leading to cracks or even collapse. The consequences of such failures can be catastrophic, resulting in loss of life and significant economic impact. The same goes for your home's foundation. Your house is designed to sit on a stable foundation, but over time, various factors can affect its integrity. The soil beneath it shifts and settles over time. This natural process can be influenced by weather conditions, water drainage, and even nearby construction activities. This can put uneven pressure on the foundation, causing cracks and other damage. These cracks can compromise the structural integrity of your home, leading to costly repairs. And it's not just about the weight itself, but also how it's distributed. Proper weight distribution is crucial in maintaining the stability of any structure. Imagine putting all your weight on one foot. It's much harder than balancing it on two, right? This simple analogy helps us understand the importance of even weight distribution in construction. Uneven loads on concrete can be just as problematic. When weight is not evenly distributed, it can create stress points that lead to cracks and other forms of damage. Knowing the types of loads your concrete is subjected to is crucial. Engineers must consider all potential loads during the design phase to ensure the structure can withstand them. It helps us design and maintain structures that can handle the pressure. By understanding and managing these loads, we can build safer, more durable structures that stand the test of time. Section 4. Environmental factors, the unseen enemy. We often think of concrete as indestructible, but the environment can take a toll. Temperature swings, moisture, and even chemicals can all cause concrete distress. Think about a concrete driveway in a cold climate. Water seeps into tiny cracks, freezes, and expands. This puts pressure on the concrete, widening the cracks and causing further damage. Then there's the heat. Extreme heat can cause concrete to dry out too quickly. This leads to shrinkage cracks, especially in freshly poured concrete. Chemicals are another culprit. De-icing salts, for example, can be harsh on concrete. They penetrate the surface and attack the cement paste, weakening the concrete over time. Understanding the environmental factors affecting your concrete is essential for choosing the right materials and protection strategies. Section 5. Plastic shrinkage and settlement cracks, early warning signs. Even with the best design and construction, some cracking in concrete is inevitable. Two common types are plastic shrinkage cracks and settlement cracks. Plastic shrinkage cracks happen in freshly poured concrete. As the concrete starts to harden, it loses moisture and shrinks. This can cause fine cracks to appear on the surface, often in a random pattern. Settlement cracks, on the other hand, occur after the concrete has hardened. They're usually wider than shrinkage cracks and often appear in straight lines. These cracks happen when the ground beneath the concrete settles unevenly, putting stress on the hardened slab. While these cracks might seem alarming, they're usually not a major structural concern. However, they should be addressed to prevent water infiltration and further damage. Section 6. Design and formwork, the foundation of a strong structure. They say a house is only as good as its foundation. This age-old adage holds true not just for houses, but for any concrete structure, be it a towering skyscraper, a sturdy bridge, or a simple sidewalk. The foundation is the bedrock upon which the entire structure stands, and its importance cannot be overstated. The same goes for any concrete structure. Without a solid foundation, the integrity of the entire structure is compromised. This is why the design and formwork of the foundation are critical components in the construction process. Proper design and formwork are essential for ensuring its strength and longevity. The design phase involves meticulous planning and precise calculations to determine the specifications of the concrete mix, the placement of reinforcement, and the overall structure of the element. This phase is crucial because it sets the stage for the construction process. Design refers to the specifications of the concrete mix, the placement of reinforcement, and the overall structure of the element. The concrete mix must be carefully formulated to achieve the desired strength and durability. The placement of reinforcement, such as rebar, is equally important as it provides additional strength and helps to distribute loads evenly. And the overall structure of the element. A well-designed concrete structure will be able to withstand the anticipated loads and environmental conditions. This means it will be resilient against forces such as wind, earthquakes, and temperature changes, ensuring the safety and stability of the structure for years to come. A well-designed concrete structure will be able to withstand the anticipated loads and environmental conditions. This is particularly important in areas prone to natural disasters. where the strength and resilience of the structure can mean the difference between safety and catastrophe. Formwork is the temporary structure that holds the concrete in place while it hardens. It needs to be strong enough to support the weight of the wet concrete and accurately shaped to achieve the desired form. The quality of the formwork directly impacts the final shape and surface finish of the concrete structure. It needs to be strong enough to support the weight of the wet concrete. This is why the materials used for formwork, such as wood, steel, or aluminum, must be carefully selected and assembled with precision. Any weakness or misalignment in the formwork can lead to defects in the concrete structure and accurately shaped to achieve the desired form. The formwork must be designed to withstand the pressure exerted by the wet concrete and to maintain its shape until the concrete has sufficiently hardened. This requires careful planning and execution by skilled workers. Mistakes in design or formwork can lead to a whole host of problems. These include weak points, dimensional inaccuracies, and even collapse during construction. Such issues not only compromise the safety and integrity of the structure, but also result in costly repairs and delays, and even collapse during construction. This is why it is essential to adhere to best practices and industry standards during the design and construction phases. Regular inspections and quality control measures can help identify and address potential issues before they become major problems. That's why it's crucial to work with experienced professionals who know how to get it right. Their expertise and attention to detail can make all the difference in ensuring the success of a construction project. From the initial design to the final pour, every step must be executed with precision and care to build a strong and durable structure.